Hey everybody! So I am kind of changing some stuff for chapter 4, and that's only because I really want us to focus on these reactions that we've been learning about for chapter 4, and then all the stuff previous to that. So we were going to move on and finish chapter 4 tomorrow, or I guess today. But instead, I want to do another day where you try to write out the reactants and the products and then try to figure out like what those products would be, balance the equation, try to figure out what type of reaction it would be. On Friday, we are going to do some more practice with that. We actually have one more step that we have to do to all of those reactions, and then that way we'll be done with everything in terms of the reactions. And then on Monday, Monday was going to be your test, but I'm pushing it back to Tuesday. And I want to push it back to Tuesday because I want to still give you that, review or homework help day on Monday if you need it. So today we're doing some more practice with the reactions. Tomorrow on Friday, you're going to finish up and we're going to give the whole picture for all of these reactions because we, again, have one more step. And then on Monday, you're going to have your review session or your homework help. And then Tuesday, you'll have your Chapter 4 test. Now, don't forget that on Saturday at noon, I also will be at Starbucks at the Deerfield Town Center Starbucks. So if you want to come there, get help, kind of talk about some maybe areas that you just want to make sure that you're really good at for your test on Tuesday, then I will be there at noon, and I'll stay till however long you guys need. So, yeah. Also, one last thing. On your Chapter 4, if you look at your PowerPoint slides, I only want us... Okay, so the last thing that we really finished up with was the displacement reactions or the activity series. And then there are a couple slides after that talk about molarity and then the dilution calculation, that M1V1 equals M2V2. So we had M1V1 equals M2V2, or that molarity was simply moles per liter. I'm not going to go over that because we've done this before. I know you've had this before. This molarity stuff is really straightforward. I'm pretty sure that we already knew how to do that in chapters before, or we've seen that in chapters before. They just talk about it again in this chapter. And then dilution calculation, M1V1 equals M2V2. That will also be fair game. So M meaning molarity, V meaning volume, molarity, volume. But the slides after that, slides 56 through 60. Slides 56 through 60. Those are about titrations. I want us to hold off on that for this chapter. So these, no, we're not going to do them right now. And that's because I want us to do these reactions and get these reactions right now for this chapter, because there are more reactions for us to do, but we're going to do them as each chapter goes on because they're different. So slides 56 through 60 over titrations, we're going to put a hold on that. We're going to do that during the acid-base chapter, okay? Because it'll cover titrations anyways in that chapter as well. So we'll hit slides 56 through 60 in acid-base chapter so we don't have to worry about those. And that's going to change your homework problems so you don't have as many. And let's see, specifically on your homework problems, you only need to go up to number 77. Any number after that. So 79, 81, 83, 85, 87, 89, 94B, 97, you do not have to do. It's not a part of your homework anymore. So anything after number 77, you can just cross it off. Don't need to do it. So we're only going to go up to problem 77 that are listed on your homework problems there. Okay, so hopefully you don't have any more, hopefully that explains everything. If not, then this video will be posted on your blog so you can kind of rewatch it if you have questions, or just send me a post or comment on the blog, or email me, and we'll be good to go. Okay, so let's do some more examples when it comes to these reactions because I think the consensus yesterday was that we were a little overwhelmed. Like, how do I know which reaction it's going to be? How do I know what my products are going to be? Your job is to try to find different patterns, and these patterns are coming by, do I see a change in oxidation state? How do I figure out if there was a change in oxidation state? I have to find oxidation numbers for everything, which I know that may seem tedious, but typically if we need to know if it's an oxidation reduction reaction or a displacement reaction, because displacement reactions we learned are also redox reactions, I have to find the oxidation numbers. In terms of ones that we kind of did like last year, let's say for example that I just give you, let's say that we have potassium iodide. Potassium iodide is heated. Say I give you this. Potassium iodide is heated. Okay, I have one reactant. That is it. Potassium iodide would be Ki. So I can write out my reactant. So I'm heating up potassium iodide. I need to make sure I draw my delta because that's symbolizing that we have heat there, or that I'm adding heat. There is only one type of reaction that I know where there's only one reactant that's present. What is that? That is decomposition. So then I have to go through my decomposition rules. I know that this is just a binary compound. I have potassium and I have iodine. If I have just two elements there that are in a compound together, it's going to just break down into their elements. So that means I'm going to get potassium. And then what's my other product going to be? Iodine. But iodine is special. It is diatomic. So now if I look at this, is this balanced? It is not, because I have two iodines here, but I only have one over here. So I need to add a 2 here, but now I have 2 Ks, so I need to make 2 Ks over here. So now it's balanced. So an easy way to figure out decomposition, I only have one reactant. So if it's decomposition, I'm going to see something is heated, or something is heated and it also has a catalyst. Ooh, what if I said potassium iodide is heated? Oh wait, potassium iodide is heated under a reaction with a platinum catalyst. Remember that a catalyst is something that speeds up a reaction. But where do I place a catalyst in a reaction? Remember, we place it above the arrow. So just like where I have my heat, I'm also going to write PT for platinum. So I have a platinum catalyst present, and I also have my heat. And we write it above the arrow because a catalyst isn't actually involved in the reaction. It's just present to be there to help speed that reaction along. So it's not actually taking part in the reaction. It's just there to push it to go faster. So one reactant I know has to be a decomposition. Okay, what if we had, let's say that I give you a solution of barium nitrate reacts with, let's do a solution of sodium sulfate. Okay, so I have a solution of barium nitrate, and that's reacting with a solution of sodium sulfate. I don't see any acid or any base here. This says it's a solution of this. That's an aqueous solution. Reacting with a solution of sodium sulfate, that's another aqueous. So this here to me looks like it's going to be, it can't be a decomposition because I have two reactants present. I see that I have two aqueous solutions, and usually two aqueous solutions that are these two compounds here end up showing the form of a double replacement, which would be a metathesis reaction, is another name for it, or what we're calling it this year. So this would tell me that I probably have a metathesis reaction, or I have a double replacement reaction. So let's just write out, I have barium nitrate. So there's my barium nitrate. It's a solution, so I'm going to write aqueous here. And then I have a solution of sodium sulfate. So then I have sodium sulfate, and that's aqueous. Okay, so this is just a simple swapping of partners. Barium is going to now go with sulfate. Sodium is now going to go with nitrate. So I have barium sulfate, and I just want to double check. Barium has a charge of +2. Sulfate has a charge of -2, so those would cancel out. So I would have just BaSO4. And if I use my solubility rules, because I want to try to figure out if I'm going to get a precipitate or not, since this is a double replacement or a metathesis reaction, if I use my solubility rules, I will find that barium sulfate is insoluble. So that means it will be a solid. And then I'm going to make sodium nitrate. And all nitrates are soluble, so that would be aqueous, AQ. Okay, so I had my reactants that I wrote out. I figured out that this is a double replacement or metathesis reaction because it's not following any pattern for a gas formation reaction. It's not following any pattern that I'm supposed to know for acid and bases. It's not a displacement reaction, one of those single displacement reactions, because that would have been a compound plus an element. So this has to be just a simple double replacement or metathesis reaction. The last thing that I need to do is balance this, because this is not balanced. So I see here I have 2 nitrates and 2 sodiums, and so I'm going to need to write a 2 in front of that, and then it would be balanced. Okay, let's try another one. What if we had, what if I have calcium sulfite reacts with, let's see, I have calcium, let's say solid. We have solid calcium sulfite reacts with, let's do hydrochloric acid. Okay, solid calcium sulfite is reacting with hydrochloric acid. So, maybe this is an acid base, maybe this is a metathesis, how do I know? First, let's just write out our reactants. Let's see what we have here. It says solid calcium sulfite. So that'd be CaSO3, because +2 charge, -2 charge. And it says it's a solid, so I'm going to write S after it. And that's reacting with hydrochloric acid. Acids are considered to be aqueous solutions, so I'm going to write HCl. That is aqueous. Okay, what does it produce? I know this is technically a metathesis reaction, but all sulfites that react, or any sulfite that reacts with an acid, any sulfite that reacts with an acid is going to produce 3 things. That is sulfur dioxide, gas, water, and salt. So I have to know, here's an acid reacting with a sulfite. That's one of my gas formation reactions. Remember, there are 4 of them. So acid with sulfite means I'm going to get 3 things. Let's just write them down here. Sulfur dioxide gas and water. And then I also need to create salt. Well, I use my sulfur dioxide. I have water here. So the salt has to be that metal and nonmetal. So here's calcium. Here's chlorine. There's my metal, nonmetal. So I must have made calcium chloride. Now, when I go to calcium chloride, how do I find its solubility? How do I find its state of matter? I look at my solubility table, and if I do that, I would see that that is aqueous. I'm going to write AQ there. Okay, so we have calcium sulfate reacting with an acid, specifically hydrochloric acid. When a sulfite reacts with an acid, it's always going to make SO2, water, SO2 gas, water, and salt. So now I'm going to look at this, and I'm going to see if it's balanced. To balance it, I just need to add a 2 in front of the HCl. So guys, a lot of this is just practicing. I mean, I know this because I see it's an acid that's reacting with a sulfite, and that's just because there's a rule that's associated with it. So tomorrow, or today, while you are going through these reactions, really look through your notes and try to get those reactions, embedded in your mind. On Saturday, I may just give you like a drill session of asking you, if this reacts with this, then what are you going to produce? If this reacts with this, what are you going to produce? And maybe if you did that as well, even if you spent time today or tomorrow in class, in your groups, doing that to one another, I promise you that will be so, so helpful. If I get a chance, I may try to make a little Quizlet thing for you with some practice ones. So I don't know if I'll have time, but I'll try really hard to do that for you before your test on Tuesday, okay? Let's do another one, guys. Okay, let's say we have magnesium oxide. Magnesium oxide reacts with, magnesium oxide, let's do carbon dioxide gas. Magnesium oxide is reacting with carbon dioxide gas. Okay, let's write what we have. I have magnesium oxide, that'd be MgO. Now, here's a question that you guys may have, and you probably are already thinking about this when I did one of them before. If they don't give you a state of matter, you can't write a state of matter. But on your products, you should be able to use your solubility table or your solubility chart to determine what your state of matter for your products will be. But if I don't say that this is solid magnesium oxide, I can't write a state of matter there, and you're not going to be counted off for that. So I have to give you that. That's something that you may not just know for the reactants off the top of your head. But if I'm dealing with I have to know in my gas formation reactions, for example, like what we did on the last one, I don't know the solubility of SO2 by looking at the solubility table. But I did know, because when I said in a gas formation reaction, I have to form a gas, SO2 is my gas, and that's always the case. Water is always going to be a liquid, and then my salt that I made is just going to be found, the state of matter will be found by using the solubility table, okay? So I have magnesium oxide reacts with carbon dioxide gas, so CO2, and I will write the G there because they specified that it was gas. So MgO plus CO2, that's going to make something. Now, this is where I have to start, again, let's ask some questions. Is this an acid, or do I see a base present? I don't see an acid or a base present. It doesn't say anything about, excess acid, or dilute acid, or excess base. So it's not an acid-base. It's not a single displacement, because I would have had just one single element and then a compound here, so it's not that. I don't have any rules for my gas formation reactions with these two specific things. So I also know this isn't decomposition reaction because I would have had just one reactant, so it can't be a decomposition. So it kind of leaves me with maybe two options. It could be metathesis, could just be like a double replacement reaction somehow, or it could be a synthesis reaction. Then I have to start thinking, if it's a synthesis reaction, I know that there are different types of synthesis reactions. Specifically, there's one that says any metal oxide reacting with any non-metal oxide will make salt, aka ionic compound. How did I know that? I know that because I memorized those different types of synthesis reactions, and that's what you are going to have to do as well. So hopefully taking off the titration and some of that extra math stuff at the end of this chapter will help us focus more on memorizing these different types of reactions. So a metal oxide and a non-metal oxide, that's going to make some type of salt. Specifically, anytime we have a metal oxide with carbon dioxide, if I think about this, I need to make some type of ionic compound. Well, I know that the first thing that has to go in front is my metal, magnesium. Well, what kind of anion can I make with oxygen and then with CO2? I could make carbonate, CO3, and that's exactly what happens. So I get MgCO3. And that is good and balanced, okay. So I just have to go through and start asking, is it an acid, is it a base? Do I have one reactant? Is this one of my rules that I could follow for gas formation? Is this, if the oxidation numbers may change, that may tell me that it could be a displacement reaction. If I had just a compound and an element, that could tell me it would be a displacement reaction. So it's just knowing your types of reactions, and that is going to be on you. You're going to have to memorize those. Let's do one more, just one more. I may have said that the last time, but I lied because I want to do another one. So let's say I have chlorine. Oh wait, sorry. Oh, I wanted to write it in words. Okay, let's say I have chlorine gas. Reacts with, let's do sodium bromide. So chlorine gas reacts with sodium bromide. Oh, let's say with a solution of. So we get that state of matter in there. Okay, chlorine gas reacts with a solution of sodium bromide. Let's just write our reactants. I have chlorine gas. Chlorine is Cl, but it's super special. It's one of those 7 diatomic, boom, Cl2. And it's a gas, so I have to write G. And that's going to react with a solution, so that's telling me it's aqueous, of sodium bromide. So that gives me NaBr. And that would be aqueous. Beautiful. Okay, element, compound. Can't be decomp, because I would only have one reactant. Can't be a double replacement reaction, because this is just an element in a compound, and in a double replacement or metathesis, I have ions transposing between 2 compounds. Is it an acid-base? No, doesn't look like an acid-base reaction to me. Is it a synthesis reaction? Doesn't follow any of the synthesis reactions that I know. Displacement reactions happen to have an element reacting with a compound. So I'm thinking this could be a displacement reaction where chlorine wants to try to take the place of bromine. But now I have to ask myself, can chlorine take the place of bromine? Can chlorine take the place of bromine? And I would look at that fantastic periodic table, and I know that the halogens go fluorine, chlorine, bromine, iodine. They're going to do the same thing as what that activity series of metals does. Chlorine wants to kick out bromine, and it is above it on the list. So chlorine could successfully kick out bromine, and it will. So if chlorine takes the place of bromine, I'm going to get NaCl, and I want to look up my solubility, using my solubility table for NaCl, and I know that that would be aqueous. And then my last thing is bromine's kicked out all by itself, the R, but bromine is one of those special 7. It is diatomic, so I need to write Br2. But now I have to say, what's the state of matter of bromine? And bromine is always a gas. Elemental bromine or diatomic bromine is always a gas. So, last thing, it is not balanced. Let's balance that. Okay, so this would be a displacement reaction. Now, let's check too, because we said that displacement reactions will have some type of redox reaction going on. I have oxidation reduction happening. So that means electrons are moving. Someone's giving up electrons, someone's losing them, and someone's gaining them. So chlorine here, elemental, it's a diatomic element, so it would have an oxidation state of 0. Sodium, always a +1, it's an alkali metal. In this case, if sodium is a +1, bromine has to be a -1. NaCl, sodium is always a +1, so chlorine in this case has to be -1. And bromine here, it is diatomic element, so it has an oxidation state of 0. Well, chlorine on the reactant side was 0, but on the product side, it was a -1. It gained electrons. So that means that in this case, chlorine is undergoing oxidation or reduction. If it is gaining electrons, because it went from 0 to -1, that means it's becoming more negative. So gaining electrons, if I go back, Leo the lion goes grrr. Gaining electrons is reduction. Chlorine is undergoing reduction. Okay, let's look at sodium. Sodium is a +1. And on the product side, it's also a +1. So the oxidation state for sodium didn't change. So bromine better change, or otherwise something's probably wrong with this. So bromine on the reactant side was a -1, but on the product side it's a 0. That means that it lost electrons. It's not as negative, it became more positive. So if chlorine's undergoing reduction, you better believe bromine is undergoing oxidation. Just going to write OXID there, so oxidation. Okay, so hopefully going through some more examples with those help out a little bit. I want you to work on this today in class. I know that this video is like at almost at 28 minutes right now. So you have about like a little less than 20 minutes to start this. But I want you to take whatever you don't finish in class for homework, bring it back tomorrow. I for sure want you to bring it back tomorrow. I'm going to post an answer key to this online for you, so then that way you can look at it. And I will post that. I'll post it tomorrow morning. So then that way I know you have the correct answers when you come into class for tomorrow. So I'll post your answer key sometime tomorrow morning for you, and then tomorrow we're going to take our last step of dealing with all of these reactions, because you're going to actually use the same worksheet for Friday that you used today. So hopefully, again, this helps. Work on these today in class. If you still feel like, oh my gosh, this is so crazy, spend time in your group trying to quiz each other on gas formation reactions, or the synthesis reactions, or what happens with specific decomposition reactions. Like, for example, if let's say, what happens if I break down or I decompose a metal chlorate? A metal chlorate is always going to break down into a metal chloride and oxygen. If you don't know those off the top of your head, then it's going to be difficult to do this worksheet. So again, you have 15-20 minutes, quiz each other, that will help. I will quiz you also on Saturday. We'll do some of that for some review. And do this worksheet tonight for homework. Your answer key will be posted tomorrow morning. Make sure you bring this to class, though, tomorrow, because I want to make sure that we use these exact same equations for finishing up that last step. You guys have a wonderful night, and I'm so excited to see you, like, in almost a week.